All right, folks, today we're going to talk about the laws of reflection. If you haven't already completed the Explorer Learning Gizmo that was assigned to you that went through some of this stuff already, please go do that now, because this is just going to be kind of a brief review of what you should have learned when you were doing that. Now, I have in front of me a few objects, some of which you're familiar with, some maybe not so much so. So let's talk a bit about what we have here. All right, so I've got a piece of paper here, and on that piece of paper, there's a line that runs up the middle, and then there's another one that runs kind of across here. Now, this line that runs across, you can see I have a mirror set up on it. Now, that block that's sitting there is just to hold it upright. Now, if you look really, really carefully at that mirror and that line, you'll notice that the back of the mirror lines up with the line, not the front. And the reason for that is that mirrors, the reflective surface, is actually at the back. It's not actually at the front. So if you take a good look at, for example, a mirror that's in your bathroom, and if you really look carefully, get up right close to it, you can actually almost, in a lot of cases, tell that it's just kind of a clear piece of glass, and then in behind it is actually the reflective surface. Sometimes it's hard to tell, and there are some mirrors where the front is the actual reflective surface, but in this case, the reflective surface is actually at the back. So I've got the mirror lined up so that the back of the mirror is on that line, and it's very important to make sure that what we're about to do actually works. All right, now on the piece of paper, there is also a protractor. Now, you at this point should be familiar with how to use a protractor, but in case you don't remember, if you look at the right-hand side, you'll see just underneath the edge of the block, you can see it says 10, then 20, 30, and it counts all the way up as you go around up to, and just buried underneath the edge of that mirror, it says 180, all right? So if we were measuring from this line over here and out, you can count the number of degrees. But you can also measure from other points. So right here, we have a line that comes out of the very center of the mirror. And if you see, it actually extends out to here, and this is what's called the normal. And we'll talk about what that is later. But that point right here is what we're gonna be aiming light, all right? We're gonna be aiming light at this point right here at the center of the mirror, right where this normal line and that 90-degree line meets the mirror. And that's what we call the vertex, all right? Now, I have over here also another object that I'm sure most of you probably have not seen before. This is what's called a ray box. And this is simply just, it's just a light. And it will shine light out of the end. And you see there's this piece right here that you can take and you can change what side is pointing down. And see here there are 3 little slits. And so if I have the light turned on, you will see 3 little rays of light will come out of it. All right, so if I switch it to 1, it'll condense all of the light down to 1 ray, and then we can follow the path of that ray of light and see what happens when it hits the mirror. Now, I have it lined up so that it is going right along that 60 mark, all right? So that 60 on the protractor is where the ray of light is traveling. Now, it hits the mirror and then bounces back. And pay close attention to where it comes back out. Now, it lines up almost perfectly with 120. Now, what do those have to do with each other? Well, they don't really seem to have any kind of association with each other. But if we compare it to this normal line, all right, so this line that comes out at 90 degrees from the mirror, you will see that the ray that goes in is 10, 20, 30 degrees. So the angle from the normal is 30 degrees of this ray. And when it bounces back, if we count 10, 20, 30 degrees. All right, now if I move this down to 50, so now we are 10, 20, 30, 40 degrees away from that normal. The ray that bounces back is 10, 20, 30, 40 degrees away. If I change this to 80, Make sure I've got that lined right up on there. You can see we're 10 away from the normal, and we're 10 away from the normal. All right, so this ray is what we call the incident ray. It is the ray that comes from the light source. This ray that bounces back is what's called the reflected ray. This is the ray that is reflected off of the surface. Now, in this case, it's a mirror, but it could be any other kind of reflective surface. This angle between the normal and that incident ray is called the angle of incidence. Right? So the angle of incidence in this case is 10 degrees because we are 10 degrees away from the normal. This angle here between the normal and the reflected ray is called the angle of reflection. All right, so 10 degrees here, 10 degrees there. Again, if I move this all the way over to 40, you can see it comes back out at 140. If we count, we have 10, 20, 30, 40, 50 degrees, 10, 20, 30, 40, 50 degrees. So the angle of incidence is 50, the angle of reflection is 50. And this is the first law of reflection, all right? This tells us that the angle of incidence will always equal the angle of reflection. Now, the question you might be asking right now is, well, why are we taking it from here? Why are we using this normal? Why aren't we just taking it from the mirror? Well, the problem is not all mirrors' surfaces are flat. This is what is called a plane mirror. It is perfectly flat. But what happens if the mirror is curved? Well, then things get a little bit different, all right? Things get a little bit more complicated. But we are going to keep it simple to start with, and we're going to just work with plane mirrors that always give us very simple, predictable results. All right?